Okay, so here we are doing question 6, mixed exercise 6 from the Statistics and Mechanics book, Statistics and Solutions. Now then, as you can see, I've already done this question, but as it says here by Certified Hood Classics, I got it wrong because it didn't make it add up to 1. Okay, and fair play to them for pointing out my mistakes. I've looked back, I've seen where my mistake is, and I will now try and go and explain the question correctly for you guys. Sorry to the 46 people who have possibly seen this done wrong, but mistakes do happen. All right, so let's go have a look at question 6 again. Okay, Stuart rolls a biased dice 4 times, and the probability of getting a 6 is a quarter. Now, he rolls it 4 times. Okay, and the probability of not 6 must be 3/4. Okay, let's have a think about this. If he rolls it once, he's got the option of getting a 6, not a 6. If he rolls it, then after that, we're up to 2, 4. We need 16 different outcomes on this, okay, for us to get how many it is. Because it's a yes, no, 6 or not 6, we need 16 different options on probabilities. So if we quickly just come down here and start drawing out a tree diagram, this is going to get a bit tight. 1, 2, 3, 4. Let's give this a bit of space. Okay. I like to draw my tree diagrams going backwards because it just makes them line up that little bit easier. 3, and can I fit it in just about? Okay. And then from here, the third roll would be these ones. Okay. And then the second roll is here, and your first roll. So what are we looking at here? We are looking at a 6 or not a 6. Okay, and this would be a quarter or 3/4. And then a 6 or not a 6, a quarter, 3/4, a quarter, 3/4. Now I'm not going to go through this and go all the way through it, but as we come through, what do we have? As we come up here on this first run here, we have rolled 4 6s. On the next one, it's been 6 6 6 and not a 6, so that's 3. 6 6, not and yes, a 6, so that's 3 again. This one has been yes yes, no no, so that's 2. This one here has been yes, no, yes, yes. Okay, so that was 3 yeses or 3 6s, and then we have got 2, and then this one has been 1 6 and 3 no 6s, so that is only 1 6. No, that one's 2, and this one is 1. Okay, so as we start building this up, you can see that there's more ways of getting it than first anticipated. So on this one, not a 6 and 3 6s. The next one down is going to be 2 6s. The next one down is going to be 2 6s again, and then 1 6, and then 2 6s, 1 6, 1 6, and no 6s. Okay, so when you start putting them together in a table, you can see that the probability, or not the probability, but the amount of no 6s is just 1. The amount of 1 6s is just 6 6s. Okay, at frequency. Number of times 1 is just 1, 2, 3, 4. The number of rolling the sixes twice is 1, 2, 3, 4, 5, 6. Getting it 3 times is 4, and rolling it 4 times, there is only one way at the very top there of getting it. Now, we need to multiply our probabilities by them. The probability of getting no sixes is 3 quarters to the power 4 times 1. The probability of getting 1 6 is going to be 3 quarters to the power 3 times 1 quarter times 4. Okay, and then for 6, or for 2 sixes, it's going to be 3 quarters squared times 1 quarter squared times 2, and then up here for 3 it's going to be 3 quarters times 1 quarter cubed times 4, and then the last one is going to be 1 quarter to the power 4. Okay, so putting them all into the calculator, so we can construct a table given the probability of distribution t. Okay, so t can be put in, and the probability of t, putting it all in. So for 0, 1, 2, 3, and 4, we will have the different answers that we've just got worked out there at the top. Okay, so 3 quarters to the power 4 is 81 over 256. 81 over 256, and that is that calculation. Okay, then we have got 3 quarters times a quarter and times 4, so 3 quarters to the power 3 times a quarter times 4. That gives me 27 over 64, which I think I'm going to multiply by 4 just to leave it all in 256s. Excellent. 27 times 4 is 108. Then we've got this 3 quarters and a quarter squared. So 75 squared plus 0.25 squared times by 6 this time. Okay, 15 over 16. Which I think is 240 over 256. That seems a bit large, doesn't it? 9. No, it's 54, isn't it? Okay. So that's 54. And then 3 times 4, 12 over 256. And finally 1 over 256. And now as we go down the line there, 81 plus 108 plus 54 plus the 12 plus the 1 is 256. So the total of all of that does give us a total of 1 coming down. Okay, so that's part A, construct the probability. So there we go, part A. Right then, part B. I've done this correct on the last one, but with the wrong numbers. Find the probability of t being less than 3. So that would be the probability of 0, 1 and 2, but not the 3, all added together. So we've got 81 over 256 plus 108 over 256 plus 12 over 256, no, 54. 54. Okay, so 81 plus 108 plus 54, 243 over 256. Okay, right then, on to part C. All right, construct a table. Right, so he rolls the dice again, this time recording the number of rolls required to roll a 6. He rolls the dice a maximum of 5 times. Let the random variable s stand for the number of times he rolls the dice. So, random variable s, he can roll the dice once, twice, 3, 4, or a maximum of 5 times. Okay. And construct the probability. Okay. Right then. So if he rolls it once and he's got a 6, the probability of that was a quarter. Okay. The probability of rolling it twice would have been 3/4 times 1/4. Probability of rolling it 3 times would have been 2 lots of 3/4, so 3/4 squared times 1/4. And the probability of rolling it 4 times until he got a 6 would have been the 3/4 cubed times the quarter when he got the 6, and then finally is going to be everything else, not there, but it's going to be the not rolling it 4 times. Okay, four times a quarter, so he got it on the 5th roll, and it's going to be the times where he rolled it 5 times without any 6s. Okay, which should be 3/4 to the 5. All right, so let's go put those into here. All right, 3/4 times a quarter is 3/16. Okay, 0.75 squared times by 259/64. Okay, times by a quarter for the next one, 27,256. 3/4 to the power 4 times by a quarter added to 3/4 to the power 5. 81 over 256. Okay, and just doing the check, all of them. 7 over 256 plus 9 over 64 plus 3 over 16 plus a quarter equals 1. So they're all nice. All right. And then finally, part D for this question. Part D, find the probability of S being greater than 2. That's going to be the probability of 3, 4, and 5. So that's 9 over 64 plus 27 over 256 plus 81 over 256. And that equals where we at? 9 over 64 plus 6 plus 81 over 256. 9/16. That's a probability of S being greater than 2. Okay. And that's the end of that one. Sorry about the mistake at the start, and thank you very much to the person who spotted it. All right. Have a good day.